Our next revision will be on topic 8, limits and continuity. Topic 8 will be asked in section A and also section B. So now we are going to look at section A first. So these are the types of questions that will come out in section A. For example, revision set 1, we have two questions on finding the limit. The first one is limit goes to negative infinity, and the second one, limit goes to a number, which is x goes to 3. Okay, look at the first one. As I said, what we are going to do here is we are going to divide by its highest power of the denominator, which in this case is x, or the square root of x squared. But remember, since the limit is goes to negative infinity, we have to divide by negative square root of x squared for the denominator part. And square root of x squared is equivalent to x. So that's why we are dividing 3x with x. And the answer that you should get is negative 3. For question B, it asks you to find the limit x goes to 3. So what we are going to do here is we'll multiply with its conjugate. And then we can factorize, simplify, substitute 3, and get the answer. In revision set 2, we also ask you to find the limit. The first one is limit x goes to a number, which is negative 1. For question B, limit x goes to 3. And for question C, limit x goes to infinity. For the first question, we have to simplify the question because we have 0 over 0 in determinate case, of course. To factorize x cubed plus 1, you will press your calculator, but you won't get 3 roots immediately. So what we are going to do is, we're going to do a long division divided by x plus 1, and you will get something like this. Make sure your long division is correct. Substitute the value of negative 1 and you will get the answer. For question B, we also get indeterminate value, which is 0 over 0. So that is why we are going to multiply with its conjugate, factorize, simplify, substituting the limit, and get the answer. For question C, again, it is limit goes to infinity. So infinity over infinity is also indeterminate. So always when we find the question limit goes to infinity, we have to divide by its highest power of denominator, which in this case is x squared. So that is why we divide everything by x squared and then substitute the value. Then you will get limit x goes to infinity equals to negative 1. For revision set 3, you also have to do a factorization to simplify your function. But then, you have to be very careful because we are dealing with a quadratic that started with negative value. So remember, as I said, your calculator cannot differentiate between the negative and the positive quadratic. So that is why you have to factorize negative first before you factorize it using your calculator. And you will get the answer like this. For the second one, limit x goes to 9. You have to multiply with its conjugate to simplify the function to get the value. And the last one, limit x goes to infinity. Again, we have to divide everything by the highest power of denominator, which in this case is square root of x squared. And again, if x goes to negative infinity, we have to divide by negative square root of x squared, which is also equivalent to x. So that's why the numerator we divide with x, and the denominator we divide by negative of x squared since the limit goes to negative infinity. Substitute and simplify to get your answer. So these are basically the type of question for topic 8 that will be asked in section A. In section B, you will be asked about vertical and horizontal asymptote, also the continuity of a function. So revision set 1, question 5a, it asks you to find the vertical and the horizontal asymptote. The steps are similar with all the asymptotes question. What you need to do to find the vertical asymptote is to equate the denominator with 0. You will get the x value and you have to check is it correct whether x equals to plus minus 5 over 2 is your vertical asymptote by finding the limit x goes to 5 over 2 minus, and also limit x goes to 5 over 2 plus, and also limit x goes to negative 5 over 2 minus, and also x goes to negative 5 over 2 plus, which your answer must be positive infinity or negative infinity. Then it is shown that x equals to plus minus 5 over 2 is your vertical asymptote. Next one, to find the horizontal asymptote, you have to find the limit at infinity. So in this case, your limit at infinity for x goes to infinity and x goes to negative infinity is half. So that's why your horizontal asymptote is y equals to half. Why this question, this solving should have plus minus infinity here, because you will get the same answer, half, because you are dealing with a function like this. Previous question, question 5a, asks about the horizontal and vertical asymptote. So in this question 5b, it asks you about the continuity and existence of limits. So the first question, it asks you to determine whether limit x goes to 4 exists or not. So we have to check limit x goes to 4 plus and limit x goes to 4 minus. Since the value is the same, which is 2, we said that limit x goes to 4 exists at 2. And it says find the value of p if fx is continuous at x equals to 4. We are using the three condition of continuity, which is the first one, f4 must exist, which we can see from the function f4 is equals to p. Limit x goes to 4 that we actually found earlier, which is equals to 2. So if these are continuous, if this function is continuous at x equals to 4, the value of f4 and limit x goes to 4 must be the same, so that is why p must equals to 2. For revision set 2, it asks whether fx is differentiable at x equals to negative 3. So many of you have asked about the differentiable question. So this is actually from topic 9, when you first learn about the first principle. So anyway, it can also be asked in topic 8 question because it involves limit. So how to determine whether a function is differentiable or not at a number? We have to find the limit x goes to negative 3 minus and also limit x goes to 3 plus. But the difference between this and the existence of limit is we must use the first principle formula. So in this case, limit x goes to negative 3 minus using the first principle formula, and also limit x goes to negative 3 plus using the first principle formula is not the same. So fx is not differentiable at x equals to negative 3. As I said just now, topic 8 also can ask you about the horizontal and the vertical asymptote and also continuity of a function in section B. So for question 5b and 5c, you have to use the condition for continuity, get the value of k. And also to find the horizontal asymptote, we just have to find the limit goes to positive infinity and also negative infinity, which in this case is equals to y equals to 1. Lastly, for revision set 3, question 5 from section B, it asks you to find the values of k if limit x goes to positive k for f(x) exists. So we have to use the existence of limits condition, which is limit x goes to k minus must be equals to limit x goes to k plus. So for k minus, since we have 5 functions here, we have to choose which function to use for k minus, which is obviously the third function, x squared plus 1. And for k plus, we must use 3x plus 1, the fourth function. We equate them to get the values of k, which is k equals to 0 and k equals to 3. And the second question, it says, hence, by using the value of k more than 0, find the value of a if limit x goes to negative k exists. So in this case, we take k equals to 3 since it asks that k must be more than 0. So taking k more than 0, using the limit x goes to negative k minus, which is negative 3 minus, and also x goes to negative 3 plus, we are going to use the first function from our piecewise function and the second function to get the value of a. So a equals to 4 over 3. So this is all about the question from topic 8 that will be asked in the exam. Remember, the first section, section A, will be asked about the limit at infinity and also limit to a number. And the second part, section B, it will be asked about the horizontal and vertical asymptote, existence of limit, and also the continuity of a function.